And in today's session, we'll be talking about regression analysis, for which I have already shared a data set with all of you. You might have received a cancer patient data set on your WhatsApp group already. I hope all of you have downloaded it, and I'll share my screen to start with that particular data sheet. The code share window link also is shared in your WhatsApp group, so you can open it up from there directly so that we can start with the analysis. So I have already opened up my Google Colab sheet here. I hope all of you know now how to reach on this sheet on Google Lab. How do you open this? If anyone is stuck anywhere, if anyone still don't remember how to open this sheet, they can quickly let me know in the chat box. Otherwise, we'll start with the session further. So the very first task we'll do here is to get the libraries, as we do every time. So in the list of libraries, the first 4 libraries will be as it is that we have used in yesterday's session and day after before that as well. But I'll get one more library today. That will be a little advanced plotting library. I'll just give you a small demo of that, like 1 to plots I'll create with that advanced library also. Later on, you can explore it further. There are unlimited options in every library, definitely, that we cannot cover side by side. But yes, I'll just give you some glimpse of that Plotly library. As you can see, this Plotly, this is a advanced plotting library that gives you very interactive plots. So I'll just try to show you a few options with this, and later on you can explore it further. So I'll just run these first, and we will just get these files active. I'll share this code in your code share window as well. So I'm writing here import necessary libraries as your first task, and the list of codes I have updated here. All of you can try this and run your libraries, and let me know in the chat box when you are ready with your libraries. Okay, great. I hope others are also able to do the same. Putting the next task here, that is to data loading. And the process, as we all know, we have to just bring our data file right here. So the very first step, if anyone missed earlier, you need to go to the file option right here on the left side menu. Just open this file option and wait for this side window to open. And here you can upload your data file. Just go to this upload button and look for your file that you want to upload. This file I have shared with all of you. So click open on this. For any kind of warning on your screen, click OK and wait for the data to get ready below your sample data here. As soon as it is ready, we can access it now. Make sure you all have your data set in this section, and then I can put here data is equal to pd.read_csv. So inside this, you can paste this path directly. So I'll write just data.head, and I can run this, and this is the file we are getting here. So I'll just close this, and we have this data file ready. I'll share this code with all of you. You can get it ready. Let me know when you all are ready with this data set. Then we will explore it further. Be responsive in chat box, because that is the only way for me to know how well you are doing it on the other side. So now you can observe in this data set that we have multiple variables in which you can observe various patient background variables such as age, gender, and country region, and even year. They show your little bit information about patient background. Then we have some generic and environmental variables also. These variables are in generic or environmental category, so they can define the exposure risk or some inherited risk if present in the patient. Then we have some lifestyle factors also listed, that includes alcohol use, smoking, and obesity levels. And then the treatment stage and type information we can see here. After this, you can observe here treatment cost and the survival years, and ultimately we have target severity score. So for this one also, you can see this is currently in the continuous format. And in this case study, because we are going to do a regression analysis, so we will consider this one as our target variable. So based on this only, we'll be doing our remaining analysis for now. Now let us observe these variables further. I'll take one step ahead. I'll state here observations on data, I'll write, and then here I'll put data.info to just quickly check information about this data. And you can observe here, quickly observe parameters available in this outcome and compare it what we have discussed yesterday, and try to give me a quick idea here what you observe from here, your description about this outcome that you are getting from data info. First run this on your side, and then let me know what observations you can make from this outcome. You can put in the chat box quickly. Anyone else? If you are able to understand the outcomes from this info function, let me know quickly in the chat box. Yes, some quick observations you are making. A target appears to be cost numeric data. We just discussed about target. We were planning to use, although you can conduct cost analysis also, definitely that is one way. But in our case study, we are planning this one as our target variable. Although maybe in future you can try one more regression analysis for the treatment cost. That is also possible. We can consider this one as a regression target as well. Even these survival years, this can be also considered as a regression target. That will also work. So you can do those case studies later based on what you learned today. Then you can consider these other variables as well, some regression variables, and you can conduct analysis for them. Okay, just let me know if you can find some variable, like some important variable in this data for which you think that a classification case study can be conducted, just for a discussion only. Do you think there are any important variables for which classification case study can be conducted?
Type of cancer, ma'am.
Yes, that can be one, definitely. So these are some of the variables that you can consider maybe sometime in future as classification variables, and maybe based on what we have learned yesterday, accordingly you can conduct some analysis for this also. Now let us move further. There is one important thing that many of you have missed to observe. Yesterday and before that also, I told you that you need to check this one very carefully, because this gives you an idea about missing values. So currently the expected number of values here are 50,000. But here you can observe that these two are not 50,000, and this one is also not 50,000. So it means there are missing values in these three columns, one missing value in these, one each in these three columns. Let me know if you all can observe this. There are missing values, at least three missing values in these three different columns, one each basically we have. So
Yes,
if you
ma'am. I
find,
just saw the first 5 row. So,
yes,
I mean, so I could not make it. From my data, I saw.
yes. So based on this, now you may have to take a decision that first these missing values must be imputed. You need to follow a procedure for that. And yesterday I told you that there are hundreds of different methods developed by researchers over the time that you can use. And even in Python itself, there are several different functions that you can try to do this. Sometime you may need to remove those columns or rows that have so much missing values. That can be also a recommendation by reviewers in your domain. And sometime it may be essential to impute things with previous or next value in that patient vital count. So maybe the previous visit to the hospital can be considered as the reference point to fill values in the missing visit entry. And similarly, sometime they may consider mean, median, or mode, etc., for the missing value count. And many other mathematical algorithms are also there. So currently for these three columns that are missing, first let us see which ones they are, whether they are numerical or categorical variables. for which we are trying to impute values. So you can observe that from D type column directly. You can see that in D type column that this one, these two are numerical columns, and this one is also a numerical column because they have float type entries. So it clearly means that we can directly use some mean or median based method may work fine. That is good. If we had missing values in some categorical variable, in that case maybe you could consider mode as your preferred technique for the categorical variable. So I'll just put here one technique. I told you one more option yesterday, that you can even see count of missing value. Although here we can directly see that, okay, only one value is missing. But sometime if you have more than one, like a large number of missing values, so you would like to see exact number of that missing value. So for that, what you can do is, I can write here is null dot sum, and we can check the count of missing value. You can observe here we have missing value at this point and at this point also. So this will show you exact count also. Okay, so I'll repeat also if some of you are late. Observe what we are doing here. Let me just take you on the top. I hope you know how we open this sheet. First confirm me. You know how we open this sheet, Google Colab sheet? Okay, great. So we'll start from here. First, I'm just putting all the essential libraries that we need. So initially, these 4 libraries we are using from past several days. You can use them directly. And then here, this Plotly library, one additional library I have added today, just to show you little advanced analytics also, like 1 or 2 advanced analytics also I'll try to put here. So for that Plotly library, I'm planning to use. And I have shared all these codes here in your code share window also. So you can first execute this section. Then we have loaded dataset. So I just took my dataset in this section. I hope all of you know how we get dataset here. You can just click on upload and get your data file right here. So based on this, you can then check your data head, and we are able to see this dataset available, out of which we are planning to consider this one as our target variable and remaining all as feature variables, so we can use them accordingly. So after observing these variables, what we were trying to do is we were conducting some observations on data just to see how its variables are organized, or if we have some missing values or not in our data. So this set of code also I have shared in code share window. And here we have quickly observed that the expected number of entries in our data were 50,000, but there are few lesser entries also in these 3 different columns. So this shows that we have missing values in these 3 columns, and there is, by default, we can see that there is one missing value. So that observation we can make from here quickly. And we were discussing also that there are multiple methods available in Python that you can use for dealing with missing values. Currently, considering the time limit, I'll just deploy one technique just to give you an idea that how you can quickly deal with it. So even if you have large number of missing values, then also you can handle them easily by just updating your relevant function into the sequence. So currently they are all float type variables. Wherever we have missing values, they are all purely numerical variables. And to deal with missing values in these variables, you can use mean or median based technique. Most common techniques you can use from that. So here I have also shown you one more way out to check count of missing values in your data. That is data.isNull.sum. Yesterday also I have discussed something like this with all of you. So the same technique I have used. And we have observed here that there are one missing value in these 3 columns, and remaining all are 0. So up to this only we have done by now. Let me know if this is clear for all of you. I'll look for responses in the chat box if everyone is ready up to this. If you have checked your missing values, then we will proceed further. Okay, so I suppose all of you are done up to this. And now I'll show you one next step. That will be to remove these missing values. And for that, I'll be using a simple imputation technique. I'll write here, impute missing values. And for that, for example, I'll use mean method. You can try different methods also later on. You can explore further based on your domain expertise as well. But just one example I'm giving you. Since we have missing values in 3 different columns, so what I can do here is I'll just go through for calls in data dot columns. So I'm creating a for loop to iterate through these columns again. And then I'll pass here data dot calls because we need to impute missing values from all those columns wherever we have missing entries. So we will just keep on iterating, and wherever it will find missing value, it will automatically impute them. So here we are writing data dot calls, and the method name we are using is fillna. Fillna method is to fill null values or fill not available values. So this will automatically fill, but we can mention the method here that how it should fill. So for that, I'm writing here that it should calculate first the mean of respective column. Observe, it will calculate mean of respective column, and that value it will use to impute that particular position wherever we have missing entries. Note that we do not calculate mean of entire data. We calculate mean of respective column only. So as we are iterating through these columns one by one, it will find each column, it will find the mean of that, and it will use that for the fill operation. So I'll just run this portion. Let me just check if we have some error. Okay, it cannot convert. Okay, fine, I can understand that. So for this, what I have to do is currently see what error we are getting. Also, this should be also known to all of you that how we are getting this kind of error. See, what I did here is I just iterated through all columns and I'm trying to fill missing values with mean. But as you all might be aware that mean we can calculate for numerical variables only. But currently we are passing all types of variable into this loop. So when it is coming to even first column, it is finding string entry here. And it cannot evaluate that mean operation on this entry because it need specific numerical values whenever it has to conduct this operation. So let us simplify this. We will just highlight the specific names of the columns for which we want to conduct this operation so that it doesn't get stuck in between. So I'll write here calls, I'll pass inside, and the name of the columns I'll write. One is genetic risk. Then I'll pick up the second column, that is air pollution. So this one also I'll mention. And third column is survival year, so that it gets only numerical columns for which it can easily do the evaluation part. So this is done from here. And now what I'll do is I'll just pass. Now for loop I'll not need. I'll just pass it directly into these set of columns. Let me see if this works. Yes, this works fine. So let me first verify if your missing values are gone or not. So I'll just copy this again and I'll paste it here. Observe, I'm just checking presence of missing values again. So after executing this, missing value should be gone now. So let us verify that. I'll just run this and I can see zeros in all sections now. Earlier we had ones wherever we had missing values. So even if you have large number of missing values, you can use this method quickly, just in one shot. You could get rid of all those missing values and they were all replaced with the mean of these respective columns. So all of you can do this now. Now later on, if you want to do like median method, if you want to deploy, so you will just replace this mean with median, then it will replace that entire analysis with median itself. Many other approaches also you can follow in the same pattern. There are a few other methods also other than Filna that also you can observe later on. So this is just a quick idea I have given to you that you can try for filling missing values. So I'm writing here, fill missing values with mean, and this should work fine. After that, again, you can check your presence of missing values and let me know in chat box when you have clean data set, when you have got rid of these missing values. I'll wait for responses in the chat box. Okay, great. So after getting this clean version of data, now we will move a step further. Let me show you a quick statistical description of this data. I hope, I'm not sure if we have used that earlier or not, or maybe we have used that with purely numerical variable, not with a categorical mix variable. So I'll just show you how you can see a statistical description of your data that follows both numerical and categorical variables. So I'll write here statistical distribution of variables as our next task. And inside this data.describe method I'll use. Whenever you have data from different platforms, like let us consider one by one. Maybe when you have data from IoT sensor networks, maybe you have installed some sensor somewhere and you are getting data from there. So that will be generally a numerical data. Some numbers, some floating point values you'll be getting from there. So while getting stats from those numbers, like maybe some pollution sensors you have installed, some weather sensors you have installed, so there also you need to evaluate stats of your variables like temperature, humidity, or gases, etc. You will evaluate stats. So there you will have complete numerical variables. So when you execute this describe function on that completely numerical data, it will show you statistical description of all variables like this. Observe here, currently from your data, it has considered only those variables that are numerical in nature. So in your case, if it is maybe sensor data, completely numerical, so it will include all variables in that. But if in case your your data has mixture of variables, like categorical as well as numerical, like we have here right now. Currently, we have mixture of this. So there are numerical variables, there are categorical variables. By default, it will skip these categorical variables. You will see that this gender and country region will not be available in that describe outcome. See, after age, there is year directly. That information is not available because by default, it takes numerical analysis of only purely numerical variables. But we have options to generate this analysis for purely categorical variables also. That is also possible. With the same method we can do. With the same describe method, I'm sharing it here. First of all, get your analysis for the numerical variables. Then I'll show you, like by using this describe function, I'll just mention here one thing, that is include object. So that in analysis, this time it includes all object entries, means all the categorical variables. Now this time you can see, now it covered all categorical variables. Although this patient ID column is not important for us, we can drop it right in the beginning. Also we can drop it. This I'm keeping by mistake for now, but we can drop it further. However, just for analysis, we can observe that all the categorical variables are kept in this. Now, let us see what is the difference between both. When you have pure numerical variable, your statistical variables will be different in nature. Like you have count of observations first for each column, then you have mean values, standard deviation is there, minimum possible value and maximum possible values there, and then you have this intermediate quartile values also. I suppose I have discussed this in third day of session when we have conducted some statistical analysis and visualization. There also we have discussed this. But when you have pure categorical variables, at that time we just get count unique entries, means how many unique classes are there in the categorical variable, what is the most frequent value, or we call the mode of respective variable. So it is finding these as mode, means the most common entries are from these categories. And then frequency of the mode variable, the topmost variable, how frequently it is appearing, that information you will find. So in this way, stats of both types of variables you can calculate quickly. Observe this carefully and let me know when you are done. So we'll move forward accordingly. Okay, great. So now we will do a little bit of exploratory data analysis. We will try to observe a few variables here. The very first I'll take is, for example, age variable. I think yesterday someone asked me that if we have to plot density curve, then how we can do that. So let me just give you a quick idea for that how you can get density plots. So for age distribution example, I'll consider this. I'll first set up my figure, although this is optional also. First, let me just show you the plot only. So KDE plot, kernel density estimation, we call this technically in data science. And I'm considering age variable for this. So I'll just plot this and you will find this kernel density estimation plot. So this curve, a simple line curve you will find for this. So ranging from which values are more popular here, accordingly this curve you will find. Quick description of how your variables are ranging from one area to other. I hope yesterday also we have observed age variable, but at that time we were using bar charts. But this is another way. You can use density plot also for this purpose. And you can observe that by default it has x-axis and y-axis values also. It will by default take that density and age. So this KDE plot works automatically on these parameters. However, the title you can add. So in order to add a title, you can take help from PLT directly, add title, and inside this I can write maybe age distribution of cancer patients, for example. So I'll just run this, and this is what we are getting as an outcome here. If you want to disable this text also, you can just write plot show after this so that this description doesn't arrive here, just the plot appears. So this is a clean version of plot you may get. I can share this in the code share window. Try this plot, just one example of density plot I have given you. Later on, you can try this with some other variables also. After running this basic plot, I'll create one interactive plot also. I'm creating here stacked bar plot. And inside this, I'll write here cancer stage distribution per country. Maybe this kind of analysis we want to do. So observe in your data that here we have variables relevant to country option details, like country region variable is there available, and similarly cancer stage I want to analyze with reference to this. So I'll just observe this one maybe. So I'll try to check an analysis between these two variables, for instance, and I'll just try to observe that how cancer stages are distributed among different country regions. Or you can try this even with your cancer type variable. For this also you can do this similarly later on. Let us do this with the help of Plotly library that we have not used in previous sessions. So I'll show you how that can offer you some interactive options. First of all, I'm creating one new variable here, stage distribution. So I'm calling it stage dist variable. And inside this here, I'll create data dot group by. I'll group this in terms of country region variable. And the second variable I have is cancer stage. These are two variables that I want to consider for now. With this, I'll mention size. This group by technique we have used yesterday also. That can quickly help you to organize your variables or group your variables by considering their individual category counts. So here both category region and country region and cancer stage are categorical variable. So it will automatically calculate size in each proportion. Like if it covers maybe 10 different countries, so how many counts or how many observations are belonging to those 10 different countries, it will evaluate that. And then cancer stages, it will see like if there are 4 cancer stages, it will also see how many observations are belonging to stage 1, how many to stage 2, and so on. And after this, I'll do one more thing here. I'll use reset index, and name here I'll pass is count. For example, when this new stage distribution variable will be created, so from this variable, if I try to observe this, what kind of variable it will appear, for example, I'll run this, and we are creating a new variable like this. Observe this. We are creating a new variable like this. And in general, by default, if we use this count variable will not appear here. But I have created it by using reset index. Otherwise, if I do not use reset index, maybe if I remove this option, see these changes very carefully, that what may happen if we do like this. Observe here. In that case, your this country region is appearing like this. It is just organizing this count variable. First Australia it is taking, then all stages of that, then count out of this. So this is appearing, these two things are appearing more like index, and this is appearing like a normal variable. So what I'm doing, I'm making it a precise by resetting index, so that this thing doesn't appear like index. It should not appear like this, but a normal table that can be used for plotting purpose. So then it is offering information in this form. So now it is giving you a tabular form, proper tabular form. So there are several options to change variable formations as per requirement. We can create new separate variables. We can update the presentation techniques of variables, everything we can do in Python. So all of you can first create this new distribution, for example, so that we can use it for a quick plotting. Just one technique I'm showing you. Otherwise, there are many other ways also to do this. This is just a quick option that if you want to evaluate a set of parameters separately, you can even organize them as per your choice. So next, what we will do is I'll try to create a figure for this. So I'll use PX. PX, you remember, this is Plotly library. Then I'm creating a bar chart because the objective I took here initially is your stacked bar plot. So I'm taking a bar chart further that you can observe here. From Plotly, I'm taking a bar chart, and inside this, first thing I'm passing is my newly created variable, that is stage distribution. Then on the x-axis, I'll keep country region, this variable on x-axis. On y-axis, now we are taking this information from this newly created data that you can find here. From this newly created data only, we are taking these variables. So on y-axis, for example, maybe I'll consider count. So count variable on y-axis. Then the color variable I'll add. The color variable, for example, I'll consider Kansas stage. So all of them get occupied on the same figure. Then title of this plot I'll create Kansas stage distribution across countries. For example, I'll pass here, and then I'll just show this figure. So I'll just run this portion and let us see what we have in outcome. It will take a little bit of time to organize your details. And now we have the plot here. So this is your plot now. Observe, first of all, the countries on the x-axis, count on the y-axis, and then this cancer stage, this label is automatically being created for the color markers. But the most important part here is this is an interactive plot. Why I'm saying that? If you hover your cursor here, it will show you the exact information associated to that bar. Wherever you take your cursor, the count and all the three variables that are associated to this graph, they are being printed side by side. So in this way, it allows you to check exact values side by side. So that is why Plotly is generally used by several researchers to create some graphs that can give quick representations for any kind of analytics that they are following. There are many other options also in this Plotly library. I think someone by mistake cut something from here. Let me just paste it again. Please do not disturb content from this code share window. Just copy it, do not cut paste anything. So you should be able to get this kind of bar chart with it. Observe this outcome and let me know if you are done with it. I'll wait for responses in the chat box when you are done up to this. Okay, great.
Ma'am,
So
can we get percentage as well?
for percentage, you may need to check if there are options. You may have to first convert this count into percentage in that case. Then only you'll be able to get, because currently we are using these variables directly from here. Na? So they will be updated. First, you may have to convert this into percentage and then you can update accordingly.
Okay.
So after this, I'll put here one more analysis. Like from the this Plotly library itself, let us see one more interactive plot that I'll create a hypothetical condition. Like maybe if we want to see a severity distribution by cancer stage, that is basically the core clinical insight we can get with reference to your target variable, because this severity distribution is your target variable. So that if you want to link somewhere with the cancer stage, for example. So what we can do here is I'll create one more figure, and this time I'll use violin plot. One more type of plot I'm showing you. You can use violin plot, for example. So after this, what I'll do here, first thing is I'll pass data. This I'm using from main data variable itself, because I'll not transform variable into any count, etc. Reason being, this cancer stage is a categorical variable and severity distribution already is a numerical variable. So we can use that directly. We need not to calculate count separately. So X I'll pass as a cancer stage variable, and Y axis I'll use our target variable. That was just a minute, I made a mistake maybe. Right. Here I'll write target severity score. So after this, one more entry I'll make is the title, for example. So inside this, I'll write distribution of severity score across cancer stages. And let us see what we get as an outcome. Okay, I'll write figure show also after this. Then only it will display the figure. So I'll run this part and you can observe the violin plots are being created. And this time, if I hover over anywhere on this violin plot, you can see all the observations are getting updated accordingly. And this is with all relevant sets on upper margin, lower margin, like min value it is showing, lower fence value it is showing, all the possible things that are required in violin plot, they are being highlighted. And whenever I'm scrolling through intermediate values, there also what is the median at certain point, what is y value at certain point, quartile value also it is showing, like when we are reaching at certain quartile level, that it is also showing. So Q1, Q3, whatever it has as an option here, that is being reported quickly. You can move to other, there also it will help you to observe these values. So these kind of plots, maybe sometime you get more interaction with them, and that becomes easier for certain kind of decision making. So currently this is with all cancer stages, and then it is just organizing this with reference to the severity scores. So it is even possible to add box plot inside this. You can even combine box plots with it. For example, I'll pass here one more variable like box is equal to true. So if I do this, it will insert box plots inside Boolean plot. You can observe these box plots inside. So depending upon what type of graphs you need, you can improve that slightly also. Depending upon what variables or what uh, arguments are permitted inside a function, accordingly modifications you can do. So I'm sharing this code also with all of you. Try this and you can see the interactions with your this violin plot. Let me know when you are done up to this. I'll wait for responses in the chat box when you are done with this. Yes, this plotly generally gives you very interactive plots. They appear very presentable for any kind of discussions further. So let me show you one more plot also. This one I'm creating for survival years distribution by cancer type, for example. So in our data, we already have both these variables. If you observe, like I'll just create data head again here at nearest possible position so that we need not to scroll up every time. I'll just put my data head once again. So here you can observe we have this survival years variable for the patients along with cancer type we can see here. So let us have a quick observation, and this time again I'm just taking one simple example. Later on you will find many other plots also. Like I'll use one simple box plot. Here I have shown you box plot inside Wallen plot, but we can create individual box plot also for this distribution. So what I'll write here is, again I'll pass the figure parameter, then I'll call my px library, I'll call the plot type, then I'll pass my data first of all. After data, you will see that pattern is almost similar in all these plots. So you just need to understand first the concept that what are the relevant variables that you have to pass. Although for beautification of your variables, you will find many other options further, but at least basic plots you can create as a beginner easily. You just need to remember that, okay, x-axis is to be identified, y-axis title is optional, you can give that as per your choice, and of course data you have to pass here accordingly. So I'm writing here survival distribution across cancer types, for example. And after this, I'll just write figure dot show and I'll run this. Let me just check. I have a typo somewhere. X is not name of the columns in data frame. Yeah, I have a typo here. So this I can run again. Now you can observe some clean box plots, and again we can hover over this. So you can clearly see quartile 1, quartile 3, median values, and the upper margins, upper fence margins. I hope many of you might have plotted box plots earlier also with some kind of data, because this is one of the most commonly used statistical distribution. So this gives you a clear pitch about how everything is distributed in your data. Currently the data we are using, this is almost balanced, so you are getting almost similar type of boxes for all different lung, leukemia, breast cancer, etc. You are getting almost similar type of box plots, but when you are getting some real time data from certain hospitals, you will see variations in that. But yes, this is like a simple way to present your data. Exported to pptx, yes, you can, I think you can get this in interactive form. Let me just check if that is possible. We can just save it and I'll just place it on the desktop. Okay, it is taking the entire session. For these plots, I think save they have restricted. Let me see if some options are available. Let me just see if one option I can observe here. I'll write, I have named it with name figure, I guess. Yes, the name is figure. So I'll write here figure, write HTML, and inside this I'll just name it like maybe interactive interactive boxplot.html. Let me see if I can save it like this. Yes, it is working, I guess. So yes, I can see the plot right here. Now I can download it. So I'll download. Then I'll see if I can interact with that plot also or not. These plots will generally be very heavy plots. So inserting them into some documents you have to think about first. Although in PPT this will work fine because PPTs generally can be heavy also. But for research papers, the interactive plots may sometimes create trouble because journals have their own limits that what size of figure you can have. Because interactive plots generally contain larger size. You can see that this is currently 4.98 MB. That is a big size for some journal papers generally. But yes, at least you can try for your PPTs or some discussions with the supervisors. In those cases, this will definitely work fine. So let me just save this and I'll see if it goes fine. Yes, we can save this. This we can interact also. And the saved version I have opened here. So I'll just share this code with all of you. You can also save this. You can export this plot as an HTML file, and later on you can also convert it easily to other formats. So this only you have to write. Observe, this figure is name of the figure that you have here, this one. So if you have any other name, you can use that. After that, you are just mentioning that I want to write it as an HTML because that is the easiest, most format you can have. And then you just have to give name of your file. So this proportion you can add for saving your plots. I'm just writing here. All of you can try this. So after this, I'll add here one more variable. Okay, box plot code, if I have not given in the code share, I'm just taking it quickly. Right, I have not pasted it. I have shared now. All of you can try that. Let me know when you are done with the box plot and you have tried saving your figures also. Then we will move forward. I'll wait for a while. Previous plot code is already given, I guess. Violin plot I have already mentioned here. This violin plot is right here. Before this, yes, violin plot only I have created. And this one, bar plot, this is also given. All previous plots I have already given. Okay, I'll just change the condition. This one I'll change. Maybe because we have lesser time, I'll not take it further with so many plots. Rather, one important plot that all of you need that is donut plot, because donut plots are also very commonly used. So let us see how you can create that. I'll use that for severity category distribution. So currently the target parameter we have is target severity score. So from there, if you need, like currently this is in the form of your continuous variable, but if you want to create some categories and you want to analyze that with reference to your cancer severity level distributions, that kind of condition I'm creating here. So first I'll set up here a categorical data. I'll extract from that target severity score that we have as a variable by the end of your sheet here. Observe this final variable, target severity score. This is in the form of numbers. So from here, if I want to create some categories first, like maybe severity score is low, moderate, and high, maybe 3 categories I'll create. And then I'll try to plot them inside a pie chart. And that pie chart, more like a donut plot, I'll try to create instead of normal pie chart. So you will see that how that interactive option we have in Plotly again. So for this, I'll go to the next step here, and one variable I'll create. I'll give it name severity category, and after this, pd.cut. Now this time I'm using the binning technique. Yesterday I have shown you if else condition technique also, and before that we have used binning technique also. You can try anything, just giving some ideas here that what we can try or what we can change. So currently the severity category I'm using with the binning score here. So first I'll choose my variable on which I'm doing my conditioning, and after this the bins I'll add. So maybe 0 to 3, 3 to 6, and 6 to 10. Maybe 3 bins I want to create, and labels for each bin. This technique we have already used, the same process only I'm following. So low, and then moderate, and then low. Sorry, high. Last one will be high. 3 categories we are creating here. So let us see this severity score data variable. This will be available in your main data sheet. We can observe. Let me just check. I forgot comma somewhere. This one, right? So by the end here, you can observe severity categories available. That will be depending upon how you have created your filters right now. So 0 to 3, 3 to 6, and 6 to 10. So it will just observe these values. Currently, all these values are, I think, 3 to 6. Yes, between 3 to 6, all these. So that is why moderate is here. But otherwise, for remaining values, the remaining entries will be also there. So first, this variable I'm creating, I'm putting this detail in your code share window also. And after that, we can just put this one into a graph. So I'll use a pie chart for that, and we'll try to see the outcomes of that. So I'll just update the code for another figure. Again, a very simple technique. We'll call Plotly library. I'll call pie chart out of that, then data, and then names I'll pass, that is severity category. For pie chart, we need not to provide X and Y axis. Rather, we just need to provide category for which we are going to design our pie chart. So I'll write here overall distribution of cancer severity levels, and then I can write here figure.show. So I'll just run this, and we can observe here. This is a normal pie chart currently we are having. This, and we can just hover here with these cursor, we can move, and it will show all 3 categories separately, and we have a label also here. But if you want to just add a hole in the middle, like in form of a donut chart, if you want to create it. So observe, I'll make a simple change. I'll insert a hole in this, a hole of maybe 0.4 size. You can change this size as per your requirement, what kind of chart you wish to have. So you can observe, sometimes this kind of charts are very presentable in comparison to pie chart. So you can use this form also. You can just add a hole in between, and this will be converted from pie chart to this form of donut chart you can have easily. So depending upon how you want to present your variables, you can choose your charts, and interactively you can show your data in the outcome. Try this and let me know if this was useful for all of you up to the level that we have done. Then we will move further. I'll just stop with the exploratory data analysis here, and then we will move to the core processing of your pipeline for machine learning model building. I'm putting more emphasis on data analytics and statistical distributions in all sessions, because majority of time in your medical domain you may need these kind of graphs, etc., more commonly, because very less number of people actually go to complete machine learning task. But yes, statistical analysis everyone has to do at initial level. So at least these simple coding techniques you can use to create very interactive plots that are otherwise not possible with simple softwares. So at least if you know basics of Python programming, you can easily create these very colorful charts to present your stats easily. I hope others are also able to do up to this. Okay, great. I can see some responses. I suppose the same for others also. If anyone is stuck anywhere, they can let me know in the meanwhile. And I'll be moving to separation of target and features now. Yesterday also we have done the same. So today in the same process, we can try that. First of all, we need to identify which variables are unwanted for us. So I'm putting data head again here so that I can just remove the unwanted variables very carefully from here. Now observe here, this time the decision I'm making based on like maybe you can consider some statistical variable sometime, you can have domain expertise. Like maybe when you are already into this healthcare domain, you might be aware that this patient ID variable is going to contribute nowhere in further decision making. Similarly, if this year is of no use, you can remove this. And for country region also, if you are not doing any country or region wise analysis, you can remove this one also. And then for example, when you are using it for this, because this is our target variable right now, na? So for this again we can consider maybe this cost factor, this is also not going to make any big difference, so I'll drop this one also. And this one we have created just for the analysis purpose, we can drop this variable also. So accordingly, I can choose the most irrelevant variable that I find based on the maybe domain expertise or whatever. Like in a peer group, when you are working, maybe your supervisors can guide you that these variables are relevant or irrelevant. Accordingly, you can proceed further. Otherwise, there are some feature engineering techniques also that we are not able to cover here right now because we have limited time. But maybe in some future course, we can talk in depth about feature engineering techniques also. There are like hundreds of different methods that you can find for feature selection and rejection statistically also. So instead of relying on domain expertise, in that case you can have statistical backpoint also for your feature selection. There are different possibilities. Currently we are doing this manually, so what I'll do is I'll create my x and y variable as we have done yesterday. So in the first category, I'll just drop some variables, I'll keep the remaining ones. So the column list I'll create here, and inside this I'll pass first was your patient ID. Note that we have Python as a case sensitive platform, so we need to make sure that whatever names these variables have here, in the same pattern we have to use them. So if something is capital, we have to use it in same form. Then second variable I'll take is maybe this country, region and year, both of them I'll drop. So I'll pass them here. Otherwise, decision can be based on your requirement. If you want to keep some variables, you can just keep them as it is. You don't need to write them in the drop sequence. Currently, I'm preparing a drop sequence. With whichever variables I want to drop from the feature category, that only I'm writing here. Later on, you can analyze it in different way also. Then I'll move forward, and this cost, I'll just remove. So I'll put this one here as well. And after this, the last variable, This one also I'll drop because this is derived from the target itself. So we don't need this one. This was just for the analysis. We have derived it. And along with these features, we need to drop the target variable also because that will not be part of feature set. That will be part of Y variable. So target also we will write here. So now variable patient ID, country region, then year. After that, treatment cost and severity category, and then target variable. All of them we are going to drop. And in the Y variable, we will just keep the target variable. That is your target severity score. So we are creating these two sections now. I'll run this. And after this, you can even verify your X head. You can see which variables are left as your target, as your features now. So you can see age, gender, genetic risk, air pollution, alcohol use, smoking, obesity level, cancer type, stage, and survival years. So only these variables are left in your X now, remaining all are removed. And in Y, we already know that we have only this single variable. So I'm sharing this separation code with all of you. You can just separate your variables and then you can check your X head also to verify whichever features are left with your data. Then we can proceed further. Let me know when you got the separated data and I'll show you the next part then.
Hello, ma'am. Just to check whether I'm understanding it in the right way. So next
Okay,
step should be encoding and scaling down. Am I right?
right, very right.
Okay.
So for the encoding, if you try to observe variable, which ones you will consider for encoding?
Categorical.
Yes, we can have this gender variable and we can have these two variables. So these three
Types.
variables will be encoding. And for the scaling option, there are multiple ways now further. Like currently, if you observe these variables, they are already on the lower scale. So probably they do not require very critical normalization or scaling right now. But this age variable specifically requires scaling. So we can take reference from statistical analysis, or we can just use our simple instinct that we will be normalizing only age, and these are already on the lower scale, so we will probably keep them as it is.
Can we think like this, ma'am? The scores which are up to 10, we won't change it. Can we
Yes,
do like that?
that way also we can think, because up to 10 they are already close to zero, so
Yeah,
the
yeah.
computation will not be very heavy. But when they are
Okay.
going very large, then computation will get heavy, and we don't want to burden our model on that computation part.
Yes, clear.
Yeah, that is very right. So we will come to the next step here, step by step. First, for example, I'll do this normalization or scaling part. So I'll write here scale age variable. That will be our first task, for instance. So I'm not creating pipeline today. Observe, yesterday I created a double-headed pipeline. I separated my numerical variables and categorical variables, and then I deployed. That way is also right. Today I'll be using one more technique that will help you to understand the possibilities. So currently for the scaling, I have only one variable that I want to scale. So a specific pipeline is not required. I'll just deploy my scalar directly on my X variable by considering age as my target. So what I'll do is from sklearn dot preprocessing, I'll import the same as we have used yesterday. I'll not make it complicated for you because you are learning it for the first time. We are using just some similar operations so that you can at least remember things at first instance. So min-max scalar I'm deploying. And then on the age variable only, I'll consider this. So from X, all the changes I'll be deploying on age variable. And then I'm just using scalar fit underscore transform. And inside this, I'll pass this age variable. Observe, yesterday we had to convert it into data frame also. Today I'm not doing that because yesterday we were using separate pipelines and those entire set of variables were converted in one go. So we were getting array as an output. But today I'm not using that big portion of data for conversion. I'm not creating a separate pipeline. I'm just deploying this operation on my original variable itself. So I don't need to convert anything into data frame because this is already in data frame and only there I'm deploying my operation. So if I run this, let me just observe. Okay, expected two-dimensional. I'll just update double bracket over here. This is one we can say essential point required when you are deploying min-max scalar directly on your inherent variable in data. So it requires double uh, square brackets here because it doesn't match with the dimension of your original encoder. So yesterday we were doing this thing by using data frame conversion, but today I'm just passing here two square brackets that will ensure that this is in adequate dimension so that it can match with the original format of your data frame. And now you can observe this age variable is updated. So I'm just running this here and you can get this code from CodeShare window. Let me know when your age is transformed, then we will try to encode the remaining categorical variables. I hope others are also able to do it up to this. Okay, great. So now we will go to sklearn again. We will pass to pre-processing and then I'll use label encoder for example again. You can use other encoders also later on. Currently, I'm using just simple label encoder. So I'll just declare this with label encoder empty brackets. Then I'll choose the columns because this time we have three different columns to transform. So I'll just list them one by one. First is your gender variable. Then we have cancer type variable. And your third variable was, I guess, cancer stage. So these three variables we are trying to transform right now. So I'm just putting these names in my category columns and then I can run my for loop directly. So I'll write here x cat calls. So in X, whenever it finds any of these variables, it will conduct its operation. That will be to transform those variables. So it will write here encoder dot fit transform. Again, we do not need to apply your data frame conversion because we are using this directly on main data itself. So I'm just transforming all the columns wherever I have these categorical entries. And then we can observe our updated data head. Just to ensure if conversion has been done fine, well or not. I'll run this and you can observe these are encoded now. And all the parameters that were in the form of here, these ones also, they are now all encoded. And in label encoder, it by default generally take your alphabetical sequences. So we generally do not recommend it for your ordinal data. Sorry, nominal data and ordinal data. For each case, we have different selection of encoders. So you just always have to observe whether you need to follow one hot encoding, your dummy encoding, or maybe you have to go ahead with label encoder, target encoder. Yesterday also I discussed all these vectors. Currently just one sample I'm creating here for you that you can convert like this and then we can update it in the next sequence. So now we have clean version of data and the next task, if anyone can predict, because everything we are done with the data right now. So what we can do after this? The data looks clean now. All the relevant things are done.
So analysis, no, ma'am. Tree, decision tree analysis.
Yes, we can do a kind of regression model we can build. But before that, there is one step that all of you are missing probably. Before creating model, there is one important step that yesterday also we have done, if anyone can remember. Just one step we have that will be a part of model creation process itself, but that is related to data.
Separating them or something? No.
Yes, separating data into training and testing set.
Yes, training
Because
and test.
to build your model, you need separate training and testing data. So we'll separate it here, separating training and testing data. And this time you people will give me the code to separate training and testing data. I hope you remember what we have done yesterday. You can take maybe reference from what we have done yesterday. Just try to do this. Just give me a code to separate train test data. Yes, you are choosing right method. You are importing right function. Now you need to deploy this. And in outcome, we need 4 different portions of data. So those 4 portions of data, that code you need to give me. Yes, looks fine. So what we need to do simply, we'll just go to sklearn, then we will choose model selection repository, and from there we will import train test split function, and it will give us 4 outcomes: xtrain, xtest, ytrain, ytest, and we will just deploy train test split along with it. And inside this, I'll pass x, y, that are your feature and target variables. Then test size. So generally, in majority of cases, you will have sizes like 75-25, 70-30, 80-20. Those are commonly used size. So for example, 25% I'll keep for testing and remaining I'll use for training. And shuffle I'll make true so that all observations get equal opportunity to enter into training and testing set. So we have run this now, and your training and testing data is separated, and we are on the final stage, that is to build your model. So here, for example, I'll run maybe 2 different models we'll try to run. One I'll do is maybe linear regression, and one I'll do is decision tree regression. So first I'll do is linear regression over here. You can run multiple models for comparison also, that also you can try, but currently just the basic form I'm using. So linear regression model, we will use sklearn dot linear model. This is the very basic model you have, like the very first model when you have studied theoretical class also. There also you have observed this is the very first model you generally go through when you are learning about machine learning modeling. So this will help you to analyze your variable relationships and deploy it. But generally, when you are working on medical field data, linear regression will very rarely work because patient data or vitals are generally non-linear in nature. So linear regression will very rarely show you good outcomes. But let us see, we'll just have a quick onset because currently the data set we have is a synthetic data set that is not exact patient data. But however, when you are getting real patient data, you will very rarely find linear regression as a useful option for you. So you can just explore that later on with your set of data that you may have from different zones. So you can try that later on. Then we are fitting this data with xtrain and Y-train. Then we will just make predictions. The process will be same. As we have deployed machine learning algorithm yesterday, exactly same process you will have. You'll just have to change the model name to regression. Yesterday it was classifier, today it is regression or regressor. Depends how it is stored in your system memories. Then fitting process will be exactly same. Your prediction process will be also exactly same. After this, the matrices will be different because evaluation matrices you have discussed on second day of this workshop. You know that there are different options for classification and regression. Can anyone mention which matrices we generally prefer for regression? Which evaluation parameters we use? Yes, that is one option, definitely. RMSC we can do. There are many other error terms also that we can do. For example, MSC, we have mean absolute error is there, mean absolute percentage error is there, plenty of options you have. And R2 score also, you might have discussed that day, R square value or R2 score, we call that. So currently I'll do just two, that is one is MSC and R2 score. Later on you can explore others also. So I'll go to sklearn again, and from the matrices section, this time, yesterday I imported accuracy score. Today I'll import mean squared error and R2 score, two things. Then I'll just print them here, MSC first of all. So for this mean squared error, and inside this ypred and ytest we will pass. Similarly, for the second one, we have R2 score, for example, and here I'll pass R2 score inside ypred, comma, ytest. So this completes your execution process for setting up a basic linear regression model. Let me check, I have a typo somewhere. Yes, this bracket is missing. Let me run this, and currently this is the outcome we are getting. MSC is 0.29 and R2 score is 0.7346. A current outcome we are having like this. R2 score generally we prefer close to 100 if we talk in terms of percentage. Otherwise, in terms of floating point values, close to 1 is fine. So 0.73 is also not a very bad, but yes, we can for the tune model, like yesterday I told you, and that is another advanced process that you have with hyperparameter tuning of your model. So that further you can try. And MSC currently is this. As you tune your model further, you can even bring it close to 0. So currently I'm sharing this basic model deployment with all of you. Run this, then I'll show you one more model also. I'll deploy decision tree regression also. Yes, that's fine. So then we have decision tree regression. I'll simply copy this and I'll make slight changes to this. Now, decision tree will come from tree repository as we have observed yesterday also. And this time, instead of calling decision tree classifier, we will call decision tree regressor. Observe, this is how the name is saved in repository. This is decision tree regressor. So we will just update it at relevant positions. Here I'll mention it as decision tree regressor. The name I'll change to DCT, for example. You can use any name that is of your choice. Just the model initialization should be exact as a function requirement. This name you can give as per your choice. There is no problem in that. So remaining things I'll keep as it is. I'll run this. And with decision tree, this is like not performing so well. R2 score went down and MSc is okay, not very good, not very bad, but yes, this is at least bad in comparison to linear regression, we can see. So in this way, we can compare multiple models. You can deploy this one also. And I'll show you one more with maybe random forest we can try, because we have little time. So let us try one more model. First, let me know when you are done up to this. Okay. Okay, so I hope others have also done this. I'll put up here one more model, that is random forest regression. And the process will be very simple. I'll just take this one. Okay, great. And I'll just replace. Now observe, random forest is although a tree algorithm, but this comes under ensemble category. Ensemble learning models are basically group of basic machine learning model. So this random forest, as you have seen in your theoretical discussion also, this is basically group of multiple decision trees. So we call it from the ensemble repository. There are many other algorithms from ensemble category are available. So I'm writing here random forest regressor, and the same name I have to import. I'll just call this one. I'll replace it here. I'll rename it with RF. Here also with RF, and here also with RF. Just this only I have to do. Then I can run this, and we can update the outcomes here. It will take a little bit of time, because by default random forest works with 100 decision trees. So it will combine 100 decision trees, and then it will evaluate your data, and then it will give outcomes. So definitely it will take time. I'll share this in the meanwhile with all of you, so that you can also execute, and then we can observe whether it gives something better or not. Yes, we can see. We can say that this is better than decision tree, although, but not much better than linear regression, we can say. So in this way, we are just getting a tentative idea about how different algorithms are working on our current data set. See, this is just a few things we have deployed. Again, I'm saying that there are still several possibilities that you can try with the Python platform. We have some limits here that we are keeping some boundaries with time, etc. But yes, there are further several possibilities. You can enhance outcomes by improving your feature engineering methods, by tuning your model performances. There are unlimited options. Sometimes we create optimization methods also. That is just advanced engineering we do further to improve our model outcomes. But at least now you know how we set up basic pipelines for regression and classification modeling, and you have just also seen how different types of models can be deployed easily by just making few simple changes. So the main highlight here is that whenever we are deploying machine learning algorithms, you have to spend more time on data pre-processing and feature engineering, etc. Because when you put bad data into a machine learning model, it will give poor outcome. But if you have pre-processed your data carefully, your feature selection rejection is also fine, and it involves proper statistical procedures to enhance your data patrons, then definitely your machine learning models will also work fine. So there is a common saying in this zone. We say that it takes 80% of time to pre-process and clean your data, and only 20% time is required for model building. That all of you might have observed in these 2 days. Like we spend our almost entire session to do pattern analysis and observe features, and only 20% we use for model building, like just few lines we write and then we deploy. What is feature engineering and how does it differ from data pre-processing? Yeah, that is very important question. So data pre-processing is generally about improving insights from all of your all of your variables. We can consider like that may involve dealing with missing values, dealing with outliers or noisy observations. That may include transformations of your variables, like we have done scaling and encoding, etc. They are generally some data pre-processing tasks. But in feature engineering, there are some additional things also. Till now, in the second day also of this course also, we have done few feature engineering methods. That was just with correlation analysis. We just tried to observe what is the relationship between different features, and based on that we can do some selections. In in-depth feature engineering further, we have some methods that helps you to check important scores of different features, that can help you to see relationship between different feature parameters with target variable, like how different patient vitals are contributing in final diagnosis of disease. So you can get complete summaries of that also in Python. You can see how different patient vitals are useful in certain decision making, or if some can be ignored without burdening our model in decision making. All that analysis we can do with the help of feature engineering. Sometimes we create new features, like on the second day or maybe third day of this workshop, we have observed how we create new variables from existing variable. That is also a part of feature engineering. Sometimes we reduce features, sometimes we increase features, sometimes we reject features, sometimes we create new combinations of features. We do trial and test with multiple combinations of features. Like if you have 20 vitals from patients, we combine sometime like 6 vitals, we see how they are performing for decision making. We combine other 8 vitals, we see how they are contributing. Like sometime you have maybe genomic profiles of patients and their regular test vitals. So you just see how only the genomic profiles are performing for decision making, how other vitals are performing for decision making. So plenty of combinations are possible. So that we in depth call feature engineering. Some selections, rejections, creation, and all those kind of things we call as feature engineering in detail. I hope that is useful for all of you. So currently in this particular workshop, because we have limited time, we are not exploring all possible advancements that are available, but we are just trying to give you some glimpse that at least you can start with the idea. And in future, definitely there are more options, more opportunities to explore it further. And definitely if you need further, maybe in future we can organize some specific web series or course for this as well, if you need to progress further in this domain. But for now, I'm just stopping here. And if we have any queries, any doubts on the topic, the house is open for all of you. Please let me know if it was fine for all of you. At least now we have done both classification and regression case studies. So both of them now you can deploy easily. Okay, I
Hello,
have
ma'am.
inserted decision tree also in CodeShare now. Yes, please.
Thank you, ma'am. Actually, I want to know, maybe because you're from engineering side, writing algorithm is very easy for you.
Mhm.
Person from medical field. So,
Yes.
can we get help for algorithm from the like AI generated ones, chat GPTs and all are there. So,
Yes, that also
can
is
it
one
work?
option that you can do. But definitely, ChatGPT, etc., can generate exact model codes for you. That is one option.
Okay.
But at least
Mm.
you should know the basics first. That at least
Yeah,
we are
yeah.
covering in this workshop,
Mm.
so that you
Yes,
can
yes. Basics we
decide
are.
whether it is working fine or not.
Yes. Will you be showing us one of those things, ma'am? Is it maybe in
I
the
don't
next
think
class,
that
not
we are
now?
covering here, but I'll try. If by the end of this course, if I can show some option, I'll try to do that.
Okay. Thank you.
Let me know if we have any other queries or anything related to the session that we have completed today. I hope all of you found it at least relevant to your domain.
Yes, definitely.
Okay, great. Thank you very much.
Ma'am, I have one question. Can I ask?
Yes, sure, please.
Yeah. What I meant was the survival years here we have mentioned is after the patient is dead. But in our in our routine data, when we collect survival value, where
Right,
some patients are dead, some patients are still surviving.
right, right.
So we usually use survival analysis for our routine work.
Okay.
In the routine statistics we do. But
Okay.
how do we use that information? Is it useful in a machine learning model or can we not use it? Because it's partial survival information. Some patients who are still alive, we cannot call that as a full survival duration.
Right, that is definitely a challenging thing because survival, if you are including, then definitely it requires complete information. Then it should be for all patients. But it is not always the case. If for the patients are still surviving, then definitely this parameter is little tricky to involve in that case. So maybe in that case, you can have it in other way, like you can code it into 0 and 1 only. The ones who have lost their life and the ones who are surviving. So maybe 0 and 1 analysis only you can do in that case.
Okay, so we can't use the numerical information. We will convert
Yes,
into a
numerical
categorical.
information will be little critical because those who
Mm.
are surviving, how you are going to analyze that in that case. But yes, there is one more possibility. If your domain expertise says that at least till time, like maybe the person is surviving, but he is getting treatment from last 3 years. So if you can use that information as its survival rating, then definitely that can be also involved.
You mean to say whether they have survived till a specific time? Yes or
Yes.
no in all
Yes,
the
if
cases?
that is still if the treatment is going on from past
Okay.
some years, at least that value you have that yes, this is still working, but that is still very challenging. You need to get proper domain expertise opinion on that, definitely.
ठीक है. Okay, ma'am. Thank you.
Okay. So if we don't have any further queries, I guess we can wind up the session for now, and we will meet again tomorrow with time series analysis, right at 6. So see you there again. Thank you very much for your patient listening today.